Hi, everyone. My name is Aaron Yee, and I'm the head of product marketing at Anjuna Security. Today, I will talk about an emerging technology that has the potential to shape the future of cybersecurity and cloud computing, and it's called confidential computing. But before diving into the bits and bytes, I'd like to explain why Anjuna was formed. Anjuna was started by Eyal Yogev and Jan Mikulewski, who met in Israel's Unit 8200. They noticed how easy it was for hackers to access sensitive data and code after compromising infrastructure. After leaving Unit 8200, Jan got a PhD in security and applied cryptography at Stanford, while Eyal led product management at various companies. When Jan finished his PhD, they teamed up to address the challenge they had previously encountered using confidential computing technology, leading to the creation of Anjuna. Anjuna has been around since 2018 and has expanded to include a world-class team of leaders in cloud and enterprise security across technical and go-to-market functions. Now, I'd like to set some context. It's no secret that the cloud drives major business benefits, such as lower IT costs, faster time to market, and increased productivity. But although most companies are leveraging the cloud to some extent, according to recent data from IDC, the majority of business applications are still hosted on premises. And these tend to be the most critical enterprise workloads that companies are still reluctant to move to the cloud. And if you ask leaders why they haven't migrated these applications, the answers are invariably the same: security, compliance, data privacy, and sovereignty. Those are the most commonly mentioned blockers. Now, those security issues share a common root cause. In the data center, you have full control over your infrastructure and the security of your data. Most IT leaders are accustomed to this kind of control over security measures. In contrast, when it comes to cloud computing, data security becomes a shared responsibility between you and your cloud service provider. While you are responsible for the security of your applications, the cloud service provider is responsible for the security of your infrastructure. When it comes to data security and privacy in the cloud, things can get more challenging. You now have to protect against external attackers and also account for insiders on both your end and the cloud service provider's end. The attack surface becomes larger, and anyone with root access to infrastructure can access the application layer and get a hold of code, data, and secrets. And these are always exposed in clear text when being processed by the application, which is just the first level of danger: data exposure. When someone has root access, nothing is truly secure. If they get a hold of your sensitive information, such as passwords, keys, or secrets, they can use them to decrypt your encrypted data, which can result in catastrophic consequences. And even if you've taken the necessary steps to encrypt your data at rest and in transit, it's still vulnerable to being exfiltrated if someone gains access to your data in use. Now, contrary to popular belief, it's not that difficult for attackers to gain root access. There are countless examples of companies that have experienced severe data breaches because attackers bypassed traditional security controls and gained root access. The companies listed here are just a few examples. Once attackers have root access, they can move laterally and conduct broader and more complex attacks with severe consequences. And traditional security measures cannot stop them. So what's the solution? Anjuna Confidential Computing Platform addresses this vulnerability by creating a trusted execution environment that isolates code, data, and secrets from all potential threats, including attackers, insiders, and infrastructure operators with root access. With Anjuna's platform, your applications run behind a hardened barrier, ensuring that your workloads can be safely executed on third-party infrastructure like the cloud. Whether you're deploying traditional or cloud-native applications, Anjuna's platform is application-agnostic and works across multiple cloud providers, providing you with reliable protection. Now, Anjuna is more than just our confidential runtime. We make it easy for organizations to leverage confidential computing with an integrated solution that covers the entire lifecycle. Everything from taking an existing application, building an image of it to run in a confidential environment, Deploying it to any cloud with a single command, running it with always-on encryption, and verifying code authenticity with cryptographic attestation, the end result is an application that can run securely in a cloud environment and can be trusted by others. The Anjuna platform utilizes modern CPUs that offer hardware-level isolation required for confidential computing. These processors include new features that can be used to ensure data confidentiality, data integrity, and code integrity, making it impossible for attackers to view or modify your data and code, even if they gain access to the machine or compute layer. Think of Anjuna as the easy button for achieving intrinsic data security and privacy. With just one command, Anjuna creates a secure enclave for your application, ensuring your data stays confidential. And this eliminates the need for complex security configurations or implementation headaches. As with other major technological shifts, hardware advancements require software platforms to unlock their full potential and make them accessible and widely used. Just as Microsoft's DOS brought 8086 servers to the masses in the 1980s, and VMware enabled virtualized servers in cloud computing, Anjuna is the platform for confidential computing. Anjuna aims to enable organizations to achieve complete data security and privacy for their applications on any cloud without requiring extensive expertise or significant changes to their applications. I'd like to now show you a quick demonstration that a colleague created.
Hello, my name is Daniel Charbonneau. I'm a Senior Solutions Engineer with Anjuna, and today we're going to show Kubernetes pods running on Azure with Intel SGX. In this demo, we'll be using a machine learning application that can identify cars in an image. The application will be running in Kubernetes pods, reading images from Azure Shared Storage, running a machine learning model on them, and writing the results to a shared location. We're going to assume there might be sensitive data in some of these images. Therefore, we will have the pod run inside an SGX secure enclave, and inside of that enclave, we will create a public-private key pair to enable encrypting the images with the public key by the data provider, uploaded into the enclave where it can decrypt and execute with the private key, ensuring that at no point is the sensitive data exposed to the provider or the machine learning admins or the company running the machine learning model. So first, we're going to take an existing Docker image, and we're going to go ahead and add some things to it. So the first thing we're going to do is install Anjuna's SGX drivers and tools. We need to define some relevant environment variables. Then we're going to go ahead and sign the manifest and copy the files. Now we're going to override the command image to run Anjuna's runtime to start the workload. For it to run properly in AKS, we will need to specify the amount of memory required. With everything placed now, we're going to go ahead and start up the workload. Now that we have the pods and containers running, we're going to go ahead and take a look at the logs just to make sure that it's up and running. And sure enough, you see the Flask application is ready to accept data. Now we're going to ask the application server running in the enclave for the public key so that the data provider can use it to encrypt his images. Now that we have the public key for the enclave, we're going to go ahead and encrypt our images. Now let's make sure that we did in fact encrypt all of those image files with the key, and as you can see, they are now encrypted. Next step will be to send the images to the Azure store and wait for the machine learning server to download and execute against them. Finally, we'll take a look at our results. Sure enough, it produced the correct results. One car, one JPEG count, as you can see for each one of them correctly. This ensures that you can send very sensitive data or images to machine workloads running in Kubernetes pods in secure enclaves, ensuring that your data is never at risk. Thank you very much.
That demo showcased a specific example, how to protect a machine learning model from insiders and cloud providers. But confidential computing enables many use cases, such as cloud transformation, secrets protection, sensitive data privacy, multi-party computation, and compliance. These use cases enable enterprises to better protect their data, comply with regulations, and scale their applications with confidence. Anjuna has helped numerous customers, including a multinational bank that needed to move a service layer to the cloud to increase scalability and decrease mainframe transaction costs. Paradigm, a liquidity provider to institutions that needed to secure customer and API accounts to grow and attract large institutional customers. And Fireblocks, a digital asset custody, transfer, and settlement platform that needed to expand a critical service and its keys to another cloud quickly and without any application development or refactoring. One Anjuna customer, a London-based multinational bank, faced system strain during the pandemic as more customers shifted to its digital services. The bank needed to move more components to the cloud to handle the surge, but data protection and regulatory compliance concerns hindered its abilities to leverage the cloud. To address this, the bank chose Anjuna's simple approach to confidential computing. With Anjuna, the bank moved a component of its digital front end to a confidential environment in the cloud, resulting in improved customer experience, reduced mainframe transaction costs, and compliance with data protection regulations. The bottom line is that Anjuna transforms security from being a hindrance to being a business enabler. With Anjuna, organizations can confidently migrate to the cloud, take advantage of cloud economics, and comply with regulations. Intrinsic data privacy opens up new possibilities for collaboration, new business models, and safer adoption of enterprise artificial intelligence and multi-party computing. That wraps up my presentation, and I hope that was helpful in helping you learn about confidential computing and the possibilities for your business. Thank you.